Module!
Ano na naman yan?
Ha? Oh. Bago module.
Sino nagbigay sa iyo niyan?
Ha? Anong bigay? Binili ko ito sa online store. Oh. Ito ay
Ano yan?
ito'y tinatawag na boost converter. According to the seller, yung 3 volts magiging 5 volts. Ayan yung kanyang mga pyesa. Eh bakit parang may maputi? Inaamag ang pyesa. Ano yun? Okay. Ano lang? Parang hinang. Flux. So meron siyang IC. Meron ding coil, inductor. Ito ay diode, mga capacitor at resistor. At ang kanyang current ay 1 ampere sa 5 volts. Talaga? Kaya talaga niya yung 1 ampere. So dito merong in. Dito yung in niya. Positive, negative, dalawa pa oh. Out dito.
O yan na naman ang gagawin mo. Diyaan.
Ha? Tetest natin kung totoo ngang 1 ampere ito. At saka tingnan natin kung nagbo-boost talaga siya, nagiging 5 volts. Kung anong voltahe ang input para maging 5 volts. Oh. Gagamitan natin ng adjustable power supply. Iseset natin sa current limit natin, mga ayan mataas yung amperahe. 1.5 ampere. Ayun 1.5 ampere at 3.3 volts. So yung current limit niya 1.5 ampere. Hanggang 1.5 ampere lang kaya niya. Ito na ang ating testing. Yung input nakakonekta sa adjustable power supply. Yung output sa tester. Okay? Oh. Tetestingin na natin. Input, power supply, output, tester. Kung ang ating voltahe sa input ay 3.7 volts. Walang output. Hindi siya pwede sa mga lithium-ion battery. Walang output. 5 volts. Kung ang ating voltage input ay 5 volts, 6 volts, ayun. Saka lang siya magkakameron ng 5 volts na output. So yung 6 volts, ginawa niyang 5 volts. Nag-boost ba? Eh hindi siya nag-boost eh. Buck converter ito. 'Di ba? Hindi siya boost. Ito ay buck converter. Kasi yung 6 volts Binabaan niya ng 5 volts. Stable. Quiescent current, 18 milliampere, 0.1 watt. Ano ibig sabihin yung kuryenteng yan? Yan yung kuryenteng kinukonsumo, kinakain ng circuit, ng board. Lahat na yan. So, gawin nating 9 volts. Nine volts, 5 volts pa rin yung output. Kaya lang, naging 5.13. Pero 5 volts pa rin. Diba? So, yung 9 volts na voltage input, in-step down niya sa 5 volts. Stable na 5 volts. Kahit taasan mo yung voltahe, kanina 6 volts. Diba? 118 milliwatt o 0.1118 watt. Ang kuryente niya, 0.013 ampere. Voltahe niya, 9.12 volts. Gawin natin 12 volts. Ayun. 12 volts, 5.13. Pasok pa rin sa 5 volts yung output. So, ano ibig sabihin yan? Ibig sabihin yan, magsimula sa 6 volts up to 12 volts, nakakapag-produce siya ng 5 volts output na stable. Pero, yung ating testing ay without a load. Wala pa siyang load. No load. Ang tawag dyan, no load. No load testing. Taasan natin ng ang voltahe 20 volts. 15 muna. 15, 5 volts pa rin, no? 'Di ba stable yung output niya, 5 volts? 20. Sa 20 volts na input, kaya niya makapag-produce ng stable voltage na output na 5 volts. So, siya ay step down. 'Di ba? Babaan natin. 16 volts, 5 volts pa rin. 13, 5 volts pa rin, 5.13. Pag dumating na yung 9 volts, 6 volts, ayun 6 volts, 5 volts pa rin. Pag bumaba na siya ng 6 volts, 5, pwede pa rin sa 5.5 volts, 5 volts pa rin. Ayun wala na. 'Di ba? Habang bumababa yan, ayun, bumababa yung input sa 3.8, wala na yung 5 volts. 'Di ba? Siya ay buck converter, hindi siya boost converter. Kasi yung input na mataas, binababa niya, ini-step down niya sa fixed voltage output na 5 volts. Without a load or no load. Ito na ngayon ang ating bagong testing. Meron tayo dito ang bagong gadget. Ito ay FX35 load tester. Gagamitan natin ng load tester para makita natin yung current output ng ating buck converter. Tingnan natin yung ating load tester. Ito, meron siyang sariling power supply na power bank 5 volts. Yung input niya, terminal block, galing yan ng buck converter. Buck converter out, then to the load tester. May screen siya, LCD. At nakakonekta din yung tester. DC. Naka-DC. Una, gagamitan natin ng adjustable power supply para sa voltage input papuntang buck converter, yung out ng buck converter papuntang load tester, at may nakakonektang tester sa input ng ating load tester. Tingnan natin kung ano yung kuryente at 5 volts. Set natin voltage input. Nakaset siya sa 12 volts, 12.09 volts. Yung output voltage, 5.13 volts, DC. Okay? Ano ngayon ang output current ng ating buck converter? Siya ba'y 1 ampere? Set natin sa 1 ampere. Dito. Gawin natin munang 1 ampere. Yun. 1.03 ampere at 5.13 volts. Parehas ng voltahe ng tester. Pag nirun ko yan, nag-ano siya, nagreklamo. Okay? Hindi siya nag-overload, over voltage. Hindi niya kayang 1 ampere. 500 milliampere. Yun. Run natin, run, pindot. Nagbo-voltage drop 3.76 sa 500 milliampere. So hindi siya 500 milliampere at 5 up volts. Gawin nating 200. 210 milliampere. 210 milliampere. Run natin. 4.53 volts. Nagbo-voltage drop. Kung 100, 150, 120 milliampere. 4.79. Diba? Hindi siya 5 volts. Kung 100 milliampere. Uy. Medyo 4.84. Halos 5 volts na. Pwede siya sa 100 milliampere yung current output at 5 volts. Kasi sa yan? Sa tester yan. Halos 500 volts DC. input voltage na 12 volts. So, ang kanyang current output, kanya mga 100 milliampere. Hindi siya 1 ampere. So, ang kanyang power output, 0.5 watt. Yun. Medyo nagre-reklamo pa nga. Diba? 40 milliampere. Sakto sa ating tester. Hina ng kuryente sa output. Here we have the block diagram of our buck converter test. In our testing, we are using a power supply, adjustable power supply. So the first condition is we set the power supply with a voltage of 6 volts. Because this is adjustable power supply, we adjust the voltage to 6 volts. And then the output is connected to the input of buck converter. What is this buck converter? This is a step down voltage converter or voltage step down converter. It step down a high voltage into a smaller voltage. So if this is 6 volts, we are expecting a small voltage or lower than 6 volts to the output of the buck converter. Okay? When we adjust the 6 volts or the power supply to 6 volts, buck converter converts the output into 5 volts. Approximately 5 volts. So it step down the 6 volts into 5 volts. Again, we adjust the supply into 9 volts since this is adjustable. Still, the buck converter outputs a voltage of 5 volts. Again, we adjust the power supply to 12 volts. The output of the buck converter is still 5 volts output. Stable. We have a fixed voltage output of 5 volts. Even with adjusting the voltage input from 6 volts, 9 volts, 12 volts, still the output is 5 volts. So that is the voltage output or output voltage across the buck converter. And into the voltage output, we connected this load tester. This FX35 load tester. What is the use of load tester? In order to know the current output. Since we know the voltage output, because we connected a tester in parallel with the load tester. So into the output of buck converter, we connected a tester or a multimeter or a voltmeter in a function of a voltmeter in parallel with the load tester. So we know the voltage output is 5 volts because of this tester or this multimeter we use. And also we need to use this load tester to know what is the current output of the circuit. When we set a 1 ampere of current to the load tester, it will sounds, or it will alarm. It means we are having an overcurrent. So the 1 ampere is not the current output of the buck converter. We are having this overload, current overloading. Then we set the current of the load tester to 100 milliampere. What happened to the circuit? Still, when we set to 100 milliampere of current to the load, the voltage is still 5 volts. It means at 100 milliampere, the voltage output is stable. So, the current output is 100 milliampere, not 1 ampere. If this is 100 milliampere, which is equivalent to 0.1 ampere, what is now the power output of the circuit? Using power formula, P, voltage, 5 volts. 5 volts times 0.1 ampere, 0.5 watts. Okay? 5 volts times 0.1 ampere, 0.5 watts. That is the power output of the buck converter. It is not 1 ampere. This is not a boost converter. This is a buck converter. It converts or step down the voltage into smaller voltage. And for the last test, we use 40 milliampere of current to the load tester. And it so happened that the voltage, as we have seen into the LCD screen of this load tester, is the same as the voltage of the tester. The same reading. We got the same reading of 5 volts, I think 5.13. So it means 40 milliampere is a very stable current, or that is the stable current output of the buck converter. It is not 1 ampere as according to the seller. It is 1 ampere, but it is not 1 ampere. It is from 100 milliampere to 40 milliampere. The current is, the voltage is stable. We can see how this buck converter converts a high voltage into a smaller voltage by tracing the connection. Let us see the connection, or what are the components used with this module. We're going to reverse engineer it, or we can trace the connection of the circuit. This is now the actual module buck converter. It looks like this. After the critical tracing of the circuit, we have this equivalent circuit. So I made this circuit equivalent to the actual module. And then we have now the big picture of the circuit. A buck converter with input of voltage at the left side and the output the right side. We have the filter capacitor or line noise line capacitor, stabilizer capacitor. Okay? And then for the buck converter, pin number 1 and 3 is connected. Some sort of bootstrapping circuit or capacitor. Another bootstrapping capacitor, C2. Another bootstrapping capacitor and resistor. In here, we also have this capacitor, resistor, and then capacitor, then output capacitor for stabilization at the output. This is a noise filter, line filter, capacitor. Pin number 4 ground, pin number 5 connected is the Schottky diode. Then we have this inductor, 100. Okay, what is this? 100 microhenry or 10 microhenry. 100 in the circuit, but equivalent to 10 microhenry. So the pin number 6 is the PWM line or the PWM pin that generates a PWM. When the time it is on, it injects a current to the capacitor, resistor, and into the inductor, causing this inductor to induce a voltage, producing a current, and to be supplied to the output side of the buck converter. During the time that the PWM generator at the pin 6 is off, because it produces an on-off wave or output. During it is off, now this inductor changes its polarity from positive to negative. It serves as now as a negative to positive. This now becomes there is a voltage produced at the coil. So it now injecting a voltage or a current back to the converter. That's why we have this Schottky diode in order to prevent a back EMF due to the collapsing magnetic field of the coil. The current flows back to the circuit instead of flowing back to the module. It flows back to the diode, and then until the current there's no current. Okay, that's the function of the Schottky diode to prevent and protect the circuit from the back EMF produced by the coil. So the output voltage is constant 5 volts. Okay, due to the resistor. This is the resistor, current sense resistor, this one, and with the resistor capacitor filter circuit that serves as the bootstrap to function or to work to make the module to work properly, to function the module properly, or to make it work properly. So in summary, we are producing a 5 volts, and the current is produced due to the oscillation or the oscillator by this pin injecting a current to the inductor, and then it flows back due to the back EMF. And because of this diode, It will prevent from damaging the buck converter. So the current produced is going back to the inductor, and the current produced is 5 volts into the output.